The surface of a part is the most sensitive and vulnerable area. Almost all failures and wear begin from the surface. That's why protecting the surface is extremely important. There are different ways to protect it. Some methods simply add a coating on the top, like electroplating or painting. Others actually change the surface itself by diffusing atoms into the material. These are called diffusion treatments, such as carburizing and nitriding. In this video, we're going to focus on nitriding. What is nitriding? Nitriding is the process of diffusing nitrogen atoms into the surface of a part. This forms a hard layer without significantly changing the dimensions of a component. And because the nitrogen atoms diffuse into the structure, there is no risk of the layer peeling off. If we look at the concentration profile, nitrogen content is the highest at the surface and gradually decreases toward the core. Nitriding mainly depends on two parameters: temperature and time. The higher temperature and time, the deeper diffusion layer. There are three main methods of nitriding: salt bath nitriding, gas nitriding, and plasma nitriding. In salt bath nitriding, the component is placed into molten cyanide salts and nitrogen diffused into the surface. In the gas nitriding, the component is placed inside a furnace and gases like ammonia or nitrogen-hydrogen mixture supply nitrogen for diffusion. Plasma nitriding. This process is similar to gas nitriding, but an electrical voltage is applied, ionizing the gas into plasma. Plasma not only supplies nitrogen but also provides part of the heat required. This process can be performed at lower temperature, so reducing distribution and dimensional change. After nitriding, the surface consists of two main zones: diffusion zone and compound zone. Nitrogen diffuses into interstitial sites of the lattice. If nitride-forming elements like aluminum, titanium, vanadium, or chromium are present, fine nitride precipitations form, usually along grain boundaries. At the very surface, nitrogen combines with iron to form hard iron nitrides like epsilon and gamma prime. This zone is very hard but brittle, and under a microscope it appears white, hence the name white layer. Because of the brittleness and potential cracks, this is not the main target. The diffusion zone is the most useful layer. The advantage of nitriding is improved wear resistance, better corrosion resistance, reduced surface friction due to a thin ceramic-like layer. In alloy steels with nitride-forming elements, properties are significantly enhanced. But in plain carbon steels, where such elements are absent, the white layer plays the main role in surface hardening. The fine hardness and depth of the nitriding layer strongly depend on the base material's hardness and its chemical composition. To measuring the case depth, the most accurate method is micro-hardness testing. Prepare a cross-section of the sample, perform hardness indentation from the surface toward the core. The case depth is defined as a depth where hardness drops to the substrate level. Different standards define case depth differently. For example, at the point where hardness is 50 Vickers above the core hardness, or at a specific hardness level such as 513. Thank you so much for your attention. I hope you found this video useful.
comment your questions, and subscribe for more tutorial videos.